So this is part 3, I believe, of this video series. We've gotten 1 through 9 done on the previous videos. We'll start on 10 through 14 on this one. So number 10, let's just jump right in. We're supposed to assign formal charge. Remember, formal charge is the actual valence electrons minus the assigned ones in the formula. And we get each of the lone pair counts, and the bonding pairs only count as half, or 1 electron. So for the first one, we got nitrogen, which starts out with 5. And in this drawing, it has 2, 4, 5, 6. So 5 minus 6 is minus 1. The carbon has 4. It has 4. 4 minus 4 is 0. Sulfur starts with 6. It has 6. 6 minus 6 is 0. On number 2, nitrogen starts with 5. It's got 5 assigned to it, 0. Carbon starts with 4. It has 4, 0. Sulfur starts with 6. It has 7. 6 minus 7, minus 1. And on number 3, nitrogen starts with 5. It now has 7. So 5 minus 7, minus 2. A bit of a red flag when you see numbers bigger than 1. So that minus 2 is probably not going to work. Carbon starts with 4, ends with 4. That's 0. Sulfur starts with 6, ends with 5. So that's a plus 1. Okay, so we have assigned formal charges to each one. That's 10A. 10B, which of these do we predict is most preferred representation? It gives you a little chart showing the actual electronegativities. We want the N being the highest electronegativity. If anything's going to be negative, it's going to be N. So that takes out number 2. And then we want them close to 0 as possible, so that kind of rules out number 3. So number 1 is the correct one. Number 1 is preferred. Why? Because the formal charges are close to 0. And the more electronegative has the negative charge. That was pretty easy. Number 11, identify the total number of sigma and pi bonds represented. Remember, each bond has a sigma. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sigma bonds. And pi bonds, if you've got a double or triple bond, those also have pi bonds. So it looks like I've got 1, 2, 3 pi bonds. So 10 sigma, 3 pi. Next, we've got this table number 12. We're filling in the missing information. The ClF3, I believe we've seen this one earlier. It has 28 valence electrons. To get that, we've got to have 2 lone pairs on the chlorine. That makes this have a T shape. And it is polar because not all the dipoles cancel out. Not all dipoles cancel. SF4. I've seen this one before. So far we've got 8 times 4, 32. There are actually 34 valence electrons for this one. So we need another pair. That makes this a seesaw shaped.
Did you get everything you needed then? Perfect. Thank you.
Seesaw is the shape, and again, not all of the dipoles are canceling, so it is polar also. The XEF4, also one we've seen in the past. It should have 36 valence electrons. If we use all 8 on each fluorine, that's 8 times 4 is 28. No, 8 times 4 is 32. And we need 36, so we got to have 2 more pairs. Put them on the center. That makes this square planar. And since the electron pairs are opposite of each other, it would be nonpolar. All dipoles are canceling. CF4 is just tetrahedral. Everything is a fluorine coming off of the carbon. There are no lone pairs. That is nonpolar. And finally, CH2F2 is going to be just like CF4, only 2 of the F's have been replaced with H, so it's still tetrahedral. But it's polar, because not everything cancels. Not all the dipoles cancel out. Okay. It's more important that you say those words than that you actually know what they mean, at least at this point. By May, you need to be able to say them and know what they mean. It'd be nice if you could do that now, but it's more important we got to keep practicing saying those words and writing those words. Number 13, for each molecule in the table below, draw the list structure, include both bonding and non-bonding electrons. So we got BF3, excuse me. The boron is electron deficient because it's boron. It's an exception. We knew that. So there's no lone pairs there. So this is trigonoplanar. Approximate bond angle, 120. Hybridization of the central atom takes 3 electron domains, sp2. And is it polar and nonpolar? Well, I don't see anything that won't cancel. Non-polar. Not that I'm aware of. This Mark Sawyer asked me a question. Okay. NF3 is the other part of that. And the lone pair on the end. That makes it trigonal pyramidal. Makes the bond angles just under, it would be tetrahedral with the 4 bonding or 4 electron domains. So it'd be 109.5, but it's a little less than that. So I'm going to say 107, just because I need a number less than 109, but not crazy less. Since there are 4 electron domains, sp3, and it is polar because not all the dipoles cancel. Again, say the words. Say the words. All right, number 14, and that's the last one. Compare the list structures of CH4 and NH3. Each list structure is a central atom with a total of 4 electron domains, but the bond angle in NH3 is slightly less than for CH4. Give an explanation. All right, so we've got CH4 versus NH3. So the only difference is this lone pair versus the hydrogen there. And the lone pairs take up a little more space. And so that repulsion causes the HNH bond, angle to be slightly compressed. So it's slightly less than the 109.5, which is what it said. So that is the end of this video. Sorry for the interruptions. It's been that kind of day. So I will see you in class on Monday if I don't see you later on today. Goodbye.